Okay, so the first thing here is just to write our trig ratios. So if we remember here, the first thing we probably want to write down is our SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then tangent is going to be opposite over adjacent. Okay, so the first angle here is n. So if we look at angle n, right, let's start with the hypotenuse is across from the right angle. So our hypotenuse here is going to be 15. Across from n, so opposite n is the 12, so that's opposite. And then next to the n is the 9, so that's adjacent. Right, so we labeled our hypotenuse first, and then we looked at the two legs. Of the two legs, 9 and 12 here, 12 was across, so it's opposite, and then 9's next to, so that's adjacent. Okay, and then we can fill in our ratios here. So cosine of n, so cosine is adjacent over hypotenuse, so that's 9 over 15. If we want to reduce that, both those are divisible by 3. So that's going to be 3 over 5. Right, 9 divided by 3 and 15 divided by 3. Okay, sine is opposite over hypotenuse, so that's going to be 12 over 15. And again, we could reduce that to 4 over 5. Okay, and then tangent is opposite over adjacent, so that's going to be 12, right? Tangent's opposite over adjacent, so that's going to be 12 over 9, which is going to reduce to 4 over 3. Okay, we can then look at the other angle here. So if we look at angle P here, hypotenuse stays the same. Okay, across from P is your adjacent, so 9 is going to be our opposite. All right, and then 12 is going to be our adjacent. All right. So sine of P, that's opposite over hypotenuse. So opposite is 9, hypotenuse is 15, so that's 9 over 15. Okay, which reduces to 3 over 5. Okay, cosine of P, cosine is adjacent over hypotenuse, so adjacent's 12, hypotenuse is 15, that's 12 over 15, which is going to reduce to 4 over 5. Okay, and then tangent of P is opposite over adjacent, so that's 9 over 12, which is going to reduce to 3 over 4. Okay, so those are just writing down your trig ratios for the right triangle. All right, so it's kind of like problem 0 or problem A. All right, if we look at number 1 here, so again, first thing we want to do is figure out if we're solving for a side or an angle. If we're solving for a side, that's our regular trig, sine, cosine, or tangent. If we're solving for an angle, that's going to be our inverse trig, inverse sine, inverse cosine, or inverse tangent. So here we're solving for a side, so what we want to do first is we want to label the hypotenuse. So across from your right angle is your hypotenuse. Okay. Circle the angle we're looking at. Okay, our two legs are x and 60. X is across from the angle, so across from 45, that's going to be opposite. And then 60 is adjacent. All right, and so again, if we have SOHCAHTOA as our mnemonic, okay, we have opposite and adjacent, so that's going to be tangent. So we're going to use the tangent function. So tangent of 45, our angle, we input the angle measure, and the output is going to be the ratio. So input's 45, output's going to be opposite over adjacent, that's x over 60. Okay, we probably could increase that a little bit. All right, and if we go, so now we got to solve for x, so we got to multiply both sides by 60. 60. All right, those will cancel out, so we have 60 times the tangent of 45 equals x. All right, if I go over to my calculator, 60, right, make sure I'm in degrees. 60 times tangent of 45, I'm going to get an answer of 60. Okay. And that makes sense because if those angles are the same angle, those two sides should be the same. So x is going to be 60. Okay, so x equals 60 here. All right, we go to the next one here. So we're solving for a side, so it's going to be regular trig. Okay, so let's label our sides here. So the hypotenuse is across from the right angle, so the side with x is our hypotenuse. Okay, circle the angle in question, the 40 degrees. 32, is it opposite or adjacent? It's next to, so it's adjacent. So ADJ for adjacent here. Okay, so if we look at our SOHCAHTOA, we have adjacent and hypotenuse. Right, this one we had tangent. But then this one we're going to have cosine. I'm sorry, that was the original one. Right, this one we had tangent. But for ours, we have adjacent and hypotenuse. Right, so for this one, we're going to use cosine. Right, adjacent over hypotenuse. So cosine, input the angle, so cosine of 40. Ratio is adjacent over hypotenuse, so 32 over x. So this times x is in the denominator, so we need to multiply both sides by x. Let's get this out of here. Okay, so our x's cancel out there, and we get x times cosine of 40 equals 32. And now we can divide, right, we're trying to get x by itself, so we divide both sides by cosine of 40. That'll cancel there, and you divide this side as well by cosine 40. So then you get x equals 32 divided by cosine of 40. So if we go to our calculator, 32 divided by cosine, make sure you're in degrees, 40, that's going to give us 41.8. Okay, I think it said round, didn't tell us what to round. I'm going to round to the 10th place, so 41.8. Okay, so x is going to be 41.8. In units, they don't give us any units, so we'll just say units. This one should have been inches, right? 60, x is 60 inches. This one they don't give us units, so we'll just write units in here. Okay, so that's number 2. Number 3 here, we're solving for an angle. So let's label our sides. So across from the right angle is your hypotenuse. Okay, circle the angle in question across from that, so that's opposite. And then the blank side would be adjacent. So we have information on opposite and hypotenuse. So again, if we look at SOHCAHTOA, as our mnemonic, we have opposite and hypotenuse. That's going to be sine. So we're going to do sine of our angle. So we need to do inverse because we're solving for an angle, right? So we're going to do inverse sine. And this time we're going to input the ratio. So the ratio is opposite over hypotenuse, so 60 over 75. And that's going to equal our angle measure. All right, solving for an angle, so we're using inverse. Okay, we go to our calculator, make sure it's on degrees. We're going to do inverse sine, 60 divided by 75. That's going to be 53.1 degrees. So 53.1 degrees is x. Right, 53.1 degrees. Okay. And number 4 here. Again, hypotenuse is your across from the right angle, your longest side. Okay, we circle the angle in question. 75 is next to, so that's going to be adjacent. So we're going to use, so if we again have SOHCAHTOA here. SOHCAHTOA. Right, we're going to use cosine. We have adjacent and hypotenuse. Okay, so we're going to use cosine regular because we're solving for a side. So cosine of input the angle measure equals, And then the output is your ratio, adjacent over hypotenuse, so 75 over x. All right, solve for x, so we're going to multiply both sides by x. So we have x times cosine 50 equals 75. We divide both sides by cosine of 50. All right, and we get x equals 75 divided by cosine of 50. So if we go to the calculator here, 75 divided by cosine, make sure you're in degrees. That's going to be 116.7. So 116.7. Right, and we don't have units there, so I'm going to put 116.7 units. Okay. Number 5, find the angle of elevation of a highway that is 3,456 feet long. That's your hypotenuse, and rises 289 feet. So we have a triangle. Right. Okay, so this is our road. Right, this here is your road. Okay, it rises 289 feet. Okay, your hypotenuse here, it tells us is 3,456. Okay, feet, right? This is feet. And we want to find the angle of elevation here. That's the angle going up. Right, here's your right angle. So we're solving for an angle, so it's inverse sine, cosine, or tangent. Hypotenuse here, this is your hypotenuse. This is your opposite across from your angle, right? We're looking at this angle down here. So hypotenuse and opposite, that's going to be sine. All right, so again, if we have SOHCAHTOA, we're going to use sine here. So sine, we're going to use inverse sine because we're solving for the angle. So inverse sine. And then our ratio here is going to be opposite over hypotenuse. So 289 divided by 3,456 equals our angle. So we put that in the calculator. What is it? 289. All right, so we're doing inverse sine 289 divided by 3,456. Okay, make sure you're in degrees, and that's going to be 4.8 degrees. Right, so 4.8 degrees. Okay. This one down here, we want to find the length of the rafter given the roof design shown below. So that's your hypotenuse. Okay, here's the angle in question. So 8 here is across, so that's opposite. Okay, so again, if we look at SOHCAHTOA, okay, we have opposite and hypotenuse, so that's going to be sine. We're solving for a sine, so it's regular trig. So sine of 31 is going to equal opposite is 8 over x hypotenuse. We want to solve for x now, so we multiply both sides to get x out of the denominator. I multiply x on both sides to get it out of the denominator. So we have x times sine of 31 equals 8. And then we can divide by sine of 31 on both sides. Okay, and then you get x equals, and then 8 divided by sine of 31. So 8 divided by sine, make sure you're in degrees, of 31. And that's going to be 15.5. They don't give us any units here, so I'm going to put 15.5 units. Okay. 7 here, again, similar thing here. We're solving for an angle this time, so it's going to be inverse. But if we look at our SOHCAHTOA here, SOHCAHTOA, okay, hypotenuse is across in the right angle. Circle the angle in question, the x, 380 is next to, so that's adjacent. Right, so we're going to do adjacent over hypotenuse. That's going to be cosine. And it's inverse cosine because we're solving for an angle. So inverse cosine. We input the ratio, which is adjacent over hypotenuse. So 380 over 450. And that's going to equal our angle measure. So if we input inverse cosine, what was it? 380 over 450. So 380 divided by 450. Okay, that's going to give us 32.4 degrees. I'm sorry, 32.4, right? Yeah, 32.4. Right, so 32.4 degrees. Right, we use inverse because we're solving for an angle. Okay, number 8, find the height of a tree if the angle of elevation is 25 through a piece of surveying equipment, and you're standing 150 feet from the base of the tree. The height of the surveying equipment is 4 feet. So here's some surveying equipment. Okay, that's going to be 4 feet high. Okay, the angle of elevation to the top of a tree. So if you have a tree. Okay, it's going to be 150 feet from the base, and your angle of elevation is 25. Okay, so we want to find the height of the tree. So we're going to need to find this height of our triangle. We'll call it x. Okay, and then we're going to have to add that 4 feet here, right? And so we know this little piece here is going to be 4. Okay, so if we just focus in on our triangle here, right, this piece and this piece would match up. Okay, but if we just focus on our triangle here, if we label our sides, and maybe I'll do this in a different color here, right? Here's our right angle, so here's our hypotenuse. So we look at our angle here. Okay, 150 is right next to, so that's adjacent. Okay, the x is across, so that's opposite. Right, so if we look at SOHCAHTOA, right, we have opposite and adjacent, so we're going to use tangent. Right, so we're going to do tangent of 25. Right, we're solving for a side, so it's regular. So tangent 25 equals opposite over adjacent. So x over 150. You multiply both sides by 150. Right, we're going to get 150 times tangent of 25. Make sure you're in degrees. And that's going to be 69.9 feet. So 69.9 equals x. Okay, and then we got to add 4. So we need to do 69.9 plus 4. And that's going to give us 73.9. So it's going to be 73.9 feet. Okay, because you want the total height of your tree here. Okay. Number 9, a ramp to Interstate 25 has an angle of elevation of 4 degrees. The ramp needs to gain 33 feet in height. How long should the ramp be? So our x here is our hypotenuse. So that's your hypotenuse. Okay, and then this here is your... So let me actually do a different color so we know what I'm adding versus what's in the problem. Okay, so x is your hypotenuse. Circle the angle in question. Across is going to be your opposite. So if we're looking at SOHCAHTOA, we have opposite and hypotenuse. That's going to be sine. So sine of 4 degrees is opposite 33 over x. And then we just simply solve for x. So we got to multiply both sides by x to get it out of the denominator. And then you have x times sine of 4 degrees equals 33. And now we can divide both sides by sine of 4 to get x by itself. Okay, so that cancels there, and you're left with x equals, and then 33 divided by sine of 4. It's going to give us 473.1 feet. 473.1 feet, right? So 473.1 feet. Okay. And then the last one here, number 10, the angle of the ramp of elevation, or the ramp has an angle of elevation of 2 degrees. Okay, the ramp is 1,050 feet long. Okay, fill in the information and find the slope. So we need to find the rise and the run. So let's call this x and then this y. Okay, let's look at SOHCAHTOA here. SOHCAHTOA. Okay, let's start with the rise here. So this is our hypotenuse, right? 2 degrees here. So this is our opposite. Okay, so we want to use sine there. So we want to use sine of 2 is going to equal opposite over hypotenuse. So that's x over 1,050. Okay, so solve for x. So we got to multiply both sides by 1,050. So that cancels there. And so we have 1,050 times the sine of 2 degrees. So 1,050 times the sine of 2. And that's going to give us 36.6 feet. Okay. And now we can do the run. So again, hypotenuse is the same. Right, this is going to be your adjacent now. Or it is just going to be the adjacent. And then your hypotenuse stays the same. Okay, so this time we're going to use cosine. So originally we used sine for this one. Now we're going to use cosine. So cosine of 2 degrees equals adjacent over hypotenuse. So that's going to be y over 1,050. Right, and then multiply both sides by 1,050. Right, and that's going to cancel. So 1,050 times cosine of, make sure you're in degrees, 2 degrees. That's 1,049.4. So 1,049.4 feet is going to be y. All right, so we can fill those in. 36, 1,049.4. Right, and then our rise was 36.6. Okay, and then the last part here wants our slope. So slope is rise over run. So, oops, there's an E in slope. So our slope here is going to be our rise, 36.6, divided by our run, 1,049.4. So 36.6 divided by 1,049.4. Right, and that gives us 0.0349. Well, let's just say 0.035. 0.035, which if we wanted that as a percent, you multiply by 100. That's going to be 3.5% here. 3.5%. Okay. And that's that, right? And this was a 9 here. That one's hard to see.